Hello and good day. My name is Varun Nagaraj. I'm the CEO of Sierra Monitor Corporation. You might know us as the maker of these insanely purple field server protocol gateways and routers for BACnet, LawnWorks, Modbus, KNX, and a host of other industrial networking protocols. So my company lives, breathes, and enjoys control networking. That's what we do. Now, additionally, I personally have more than 20 years of experience in the fields of data communications and networking. So it's a passion of mine well before I had the opportunity and joy of leading Sierra Monitor Corporation. While speaking with Ken and Eric from Control Trends, one of the things we talked about was the fact that it would be nice to have a series, a video series, if you will, a series of conversation or vignettes that talked about networking and its applicability and impact and importance to the area of controls, industrial controls, commercial controls, building controls, instrumentation, process controls, and so on. So we felt that such a series of conversations could add value to the Control Trends community, and therefore we decided we'd give it a shot. So one of the conversations we had was about what do we want to include in one of these conversational pieces. And we felt there were three things we wanted to include and keep in scope as we went through these discussions. One, there are a significant number of big, interesting trends that are happening in the marketplace, in the industry, that are of relevance to our community. There's a lot of information that's out there, and we thought there might be some value in having someone trustworthy curate that information for you and sort of present what we think are in fact the big drivers that all of us in the community should be aware of, helping us build, if you will, a common language, a common dictionary of terms for us to consider. The second thing I think we would want to discuss in any of these conversational pieces would be the impact of those trends on technologies. At the end of the day, we're all implementers, we're practical people who either invent things, who implement things, or who use things. And so what do those trends mean from a point of view of technology and technology implementation? And the third point is really around business models. We've long had a traditional structure where OEMs do their share, integrators or designers and specifiers have their specific responsibilities, and end users or facilities managers have their set of responsibilities and roles, all pretty clearly defined. But we think that some of these trends and some of these big events that are underway potentially change this long-standing equation. We believe that the role of OEMs could change. We believe the integrators could do a lot more or a lot less going forward. And we believe that facility managers could demand a lot more and can get a lot more. They might outsource a lot more, or they might choose to do a lot more inside. So in business parlance, we refer to it as the value chain and the players in the value chain. And this dynamic between the various players in the value chain, the OEM, the integrators, and the users, we think is changing. So no discussion really on networking and its relevance to the controls community would be complete without having a discussion about the business model and how that is going to get affected as well. So with that said, let's plunge into sort of the first set of topics we'd like to cover in this particular session. So let's begin by talking about the one trend that is starting to impact us and our industry now, and will most certainly be impacting us, our lives, how we live, and how we run our professional lives 10 years, 15 years, 20 years from now. This is the mega trend that I think everyone in the industry needs to be aware of and craft an appropriate response to. And this trend is the Industrial Internet of Things, or the IIoT. Now, you have no doubt heard something or the other in the press about the Internet of Things, or what people refer to as the IoT. There are as many definitions as there are people talking about the Internet of Things, but one simple way of looking at it is the notion that it's really about everyday objects. Now, mind you, these are not dumb objects. These are objects that have some level of sensing in them, some ability to take action, or what are called actuators, some processing in them. So it's really about these smarter everyday objects, if you will, communicating with each other, communicating with computing systems, communicating with people, sharing information, so that a greater level of insight is available to everybody, and a greater level of control, and with that, productivity and other good attributes are available to everybody. So it's really about connecting the physical world with the virtual world, if you would like to look at it in that fashion. So that's what the Internet of Things is. It's obviously a topic of conversation, and very popular examples are the Nest thermostat, for example, a smart object that you can connect to over your iPhone or your Android phone that gives you information on what's going on in the house and can take autonomous action to try and minimize your energy bill. The Fitbit that some of you more athletically inclined folks might wear, that tracks your movement, that keeps logs of your activity, and that allows you to then subsequently modify your behavior, would be another example of an IoT device. It's an everyday object, a wristband if you will, but that's being used in order to improve your life, in order to give you better insight, in order to give you better control over your life. A garage door opener that is connected to the internet, something that perhaps notifies you if you drive away from your home without closing the garage, perhaps gives you the opportunity to close that garage. That would be another example of the Internet of Things. But note that all of these are very consumer-oriented examples. The far more interesting and frankly more profitable to everybody concerned segment of the Internet of Things is the Industrial Internet of Things, or what we call the IIoT. So the Industrial Internet of Things is really the IoT applied to working settings. So what are those settings? Office buildings, commercial buildings, factories, hospitals, other areas of work, and these could be ad hoc outdoor areas like an oil rig. These could be structured workspaces like a factory. These could be plants that are automated all the way through. They could be smart cities where a bunch of these systems come together to make the city's standard of living and the people's standard of living higher. It could be smart transportation. All of these are environments or settings, and I think that's a good word, settings, where useful work gets done. So the IoT applied to real-world working settings is really what the Industrial Internet of Things is. Another way of looking at it, coming back to our theme of networking and the controls industry, is you can think of the Industrial Internet of Things as control networking in industrial environments. Now, it's tempting to dismiss the Industrial Internet of Things, or the IIoT, as just old wine in a new bottle. You know, the cynics amongst us might say, how is this different than the control networking or the process automation or the instrumentation we have done all along? Is it really just that being called something else? There's a certain amount of truth to that, but that isn't the entire story. So if you take a look at what it is that makes up the Industrial Internet of Things, at one level, there is certainly an element of taking traditional industries like instrumentation, process control, and automation, industries that have been around for a while, industries we work in today, and adding to it a dash of new technologies that are inspired by the IoT. Now, what might these new technologies be? What might these enablers be? And these enablers are advances in new sensing and actuation technology. So there's a lot of advances that are allowing us to sense more things more cost effectively. There are advances in communication. So there are many, many more ways in which devices can connect to the outside world, combinations of wired and wireless methods. Another technology that has now come into play is the ability to put this data in large structured and unstructured formats into the cloud. Another technology that is equally relevant, and again relatively new, is the ability to take a look at this data, both the structured and unstructured data, and look for insights, or what folks would refer to as analytics or big data analytics. So it's really about taking our traditional industries we work in, infusing a dash of new technologies, the four that we talked about, sensing, new communications, cloud, and analytics, and transforming that into something that produces a much higher level of productivity than what the industry has produced in the past. But there is a second component as well, which is what makes the IIoT all the more exciting. Traditionally in the past, there have been a host of unconnected objects, dumb objects. Take a manhole cover, for instance. You know, it's a piece of metal that just lies on a street. Now imagine a smart city where that manhole cover now is a slightly smarter device with the ability to perhaps communicate its sensing of the environment around it, whether there is water or not, if it's standing water or running water, and being able to communicate that into the larger fabric of intelligence around it. So suddenly you've taken a use case, or you've taken a class of objects that were dumb and unconnected and turned them into smart connected products that can now contribute to and join the conversation about all of the intelligent things that are in the environment around us. So that's what makes the industrial Internet of Things exciting. It is a dash of new technologies to an environment and an industry we know well and love. But it's also the bringing in of new applications, new companies, and new sectors, frankly, into this fabric called the industrial Internet of Things. Exciting stuff. Then the question arises, it sounds exciting, but how big is this? Is this really a significant opportunity? And the answer is, it is. I could have used one of 10 different industry pundits or forecasters and their forecasts in order to make my point, and I picked one of the more conservative ones. This particular forecast essentially prognosticates that there will be about 50 billion, that's billion with a B, connected devices that are part of the Internet of Things. 50 billion things. Now put that in perspective. 6 billion folks on planet Earth. Each of us maybe carries a cell phone or a mobile phone. Maybe half of us have computers. All right, so that takes you to maybe 10 billion, 15 billion phones and computers. What are these other 35 billion things? And yes, some of them are probably Fitbits. Some of them might be your, iWatches or Pebble watches, for those of you that still like your Pebble. Some of them might be your smart thermostats at home. But a majority of these 50 billion things over time, so by the time you get to 2025, the majority of these things are hardworking industrial things. These are devices or products that are in everyday prosaic settings. They're out there acting as pressure sensors and flow meters, or they're acting as VAV controllers. They're acting as blinds and room controllers. They are in lights. These are everyday objects that are now part of the 50 billion strong Internet of Things. So the industrial segment of the Internet of Things, or what we refer to as the IIoT, or the industrial Internet of Things, is going to be the most vibrant, the most economically significant part of the Internet of Things. There are always trends that one can ignore and say this will never happen. And I'm sure there were folks out there that saw the first automobile and said, people love horses. They will never change from their horse-drawn carriages. Those folks didn't live too long. Change happens, and while there are many, many reasons to resist change, such as saying our industry will never be comfortable with our data being on the internet, change happens. And I think it is worthwhile to potentially debate when exactly the change happens, but I think debating whether the control industry as we know it today migrates over into this industrial Internet of Things is a futile debate. Timing, yes. Inevitability, certainly not. So what are the technology ramifications of the industrial Internet of Things? What technology concepts or architectural constructs should you have in your mind as you examine how the IIoT impacts your area of work? And every vendor has their own self-serving view, if you will. But part of this series is really about trying to put together a language or a vocabulary that is really common and not specifically aligned with one vendor's view of the world. So I'll use here the Industrial Internet Consortium as a source of material. The Industrial Internet Consortium was founded a few years ago as several companies in the networking, communications, automation, and industrial sectors realized that there needed to be a common way of looking at what technologies were required in order to enable the industrial Internet of Things. And so the consortium here, the Industrial Internet Consortium, whose website iiconsortium.org is on the slide as well, recently came out with a reference architecture that I think is an invaluable contribution to our community. So let me encourage you all to actually go to that website and download this 120 page reference architecture document that they published. So I'll just highlight a couple of key things here, and I think it's an important enough concept that we probably should do another session just focused on this three-tier architecture. But the architects have essentially recommended that you look at the technology platform required to enable the industrial Internet of Things in 3 layers or 3 tiers. There is an edge tier, which is where the devices and the gateway go. There is a platform tier, which is really about collecting the data from these gateways and bringing it into some sort of a common format and a common area to structure that particular data or to store that particular data. Now, this platform tier may be a premises-based software platform, or it might be a cloud-based software platform. And the third tier really is the enterprise or the application tier, and this refers to the set of applications, the dashboards, the reports, the analytical queries, and so forth, that are written on top of the platform. And this certainly does require domain expertise. So the reason for splitting these 3 tiers is physically they could be in different locations, logically they do different things, and skill-wise or competency-wise, they do certainly address 3 different competency buckets. So this 3-tier architecture, along with the networks, if you peer closely enough at the diagram, you will look at the concept of a proximity network that uses a certain class of gateway. You will look at sort of remote moving devices that might use another gateway, which is more cellular oriented, the ability to bring it into a cloud platform, and the ability to write applications on top of these. These make up basically the reference architecture. Now at Sierra Monitor, this entire landscape is one of interest to us, and as we innovate and provide new technologies that are compliant with this architecture, we'll be happy to share that with you as well. And as we said, I think this topic is complex enough to merit its own page. But this is not a bad framework to think about when folks begin to talk to you about the IIoT, and as a practical person, you begin to map that kind of discussion into what does this mean from a technology perspective. The concept of these 3 tiers and the concept of networks connecting them and sort of different technology sets allows you to make sense of otherwise what will be a cascading avalanche of different technologies and buzzwords being thrown at you. It's not that complicated, and I think this particular framework helps simplify the noise that you will no doubt be subject to. So the technology platform required to support the IIoT is one thing. The business platform and the business implications, the value chain required to support this transformation of our industry is going to be a whole separate matter. And this is one which is going to be fairly dynamic, and us old dogs in this industry are going to have to accept the fact that certain assumptions we have made about who does what, what's allowed, what's not allowed, are going to be challenged and are probably going to look quite different 5 or 10 years from now relative to how they look today. So this slide has a set of questions, and I don't know about you, but people react to a slide with questions in one of 2 ways. One approach is to say, what are you, lazy? Couldn't you provide the answers? Why are you asking me the questions? That's one way to look at it. The second way, which frankly as an engineering student I enjoyed in the rare liberal arts or philosophy classes that I took, were when there was a single question that asked, what is humanity? And the whole class was just about that one question. Well, so it's more than one question, but there are a set of questions here to answer about business models. So let's just walk through a few. And these are all questions without clear answers today. And that's really the point I'm trying to make, is that together as a community over the next 5-10 years, these are the questions that we have to answer. And frankly, each of these questions might have multiple answers. So let's begin with an easy one. We know that in the software industry, increasingly more and more software is sold as software as a service. You used to spend millions of dollars on an Oracle or a SAP implementation. Today you might spend $100,000 a year on a Salesforce.com application, which is a software as a service application. So pretty much the majority of the software industry has transitioned, or is in the process of actively transitioning, from the old license-based model to a software as a service model. Now think about the IIoT and its implication on products. Now, is it possible that products, which today are the physical embodiment of a bunch of atoms, might actually be offered up as a service? Now, what does that mean? It might mean that the OEM, instead of actually selling you a product, such as Michelin trying to sell you a tire, actually sells you a service, meaning you rent or you lease that particular product and you only pay for it based on the usage of that particular product. This would be the equivalent of Michelin only charging you for the miles that you drove as opposed to actually charging you for the tire. And this kind of a transformation from selling a physical embodiment of a device or a product to actually selling a usage-based service would only be possible if that product were smart, connected, and providing its usage information constantly, along with other relevant information, back to some place, the owner of the product, that could make these decisions to figure out how to charge for that particular product. Now, will that happen in our industry? Will it happen next year? Will it happen in 5 years? Might it happen in certain sectors but not in others? All open questions. But we need to keep an open mind that technology changes like the IIoT can fundamentally enable or open up the window to different kinds of pricing options, like in the case of products as a service. Now, by having instantaneous real-time insight into the various devices in the field, will the OEMs or the user or the integrator that actually implemented it all be able to operate the products any better? Might they be able to run it at peak efficiency because they know constantly how well that particular product is being used? Because they have insights on how to make that product run more efficiently because of all the insight they have from how the products are doing in other installations. And all of this information is real time, and therefore each product gets tuned up to work at peak efficiency. Continuous commissioning is a way of looking at it, within our industry. Now, what about servicing these products better? What if we didn't have to wait for routine maintenance windows? What if we knew upfront that a certain product was nearing the end of its life because perhaps it was degrading at a faster pace than anticipated? Or on the other side, perhaps the product is holding up extremely well and it might be unnecessary to go and replace the product on a routine maintenance cycle. So the way products are operated and the way products are serviced could change. And the question is, who is the one monitoring the changes and who might recommend that shift from doing maintenance, from doing scheduled maintenance to predictive maintenance? Is it something that OEMs would take responsibility for? Is it a functionality that the facility manager or the user basically looks to exercise themselves? Or is this a value-added service that an integrator could provide to their customers? All questions about who does what and who charges for what. Now, could an OEM, for example, look at the product data they have constant access to? Could they take a look at that and change the design of their product so the product is cheaper or the product works more efficiently or the product does something unique? Because the OEM's engineers realize that they might have designed the product for one purpose, but as they watch in real time the use of that product, they realize that the customer's misbehavior, as some business analysts like to call it, in fact points to the fact that the product should in fact be providing another piece of functionality that the user is somehow hacking together. What if the product provided that piece of functionality as a core value proposition of the product itself? So this would be another example of how the fact that the device is now a smart, connected device with people having access to that information, the OEM in this case having access to his device's information, allows the OEM to radically improve the performance, the functionality, or the price curve associated with that product. Then there are more existential questions. Who owns the data? So if a boiler company is producing data from the boiler, and that's being fed into a building management system, which is operated by one of the big four or big five, building automation companies, how does a boiler company get access to the data that they're producing? And who owns it anyway? Is it the boiler company's data? Is it the building automation system vendor's data because they're the ones integrating it? Or is it the user's data? And is the user willing to share that data back with the boiler company so that the boiler company can perhaps reduce his operating costs? This question as to who owns the data, how you share the data, who has access to what data, they're all unknown questions. They're all unknown answers. The questions are known, the answers are not. And frankly, there could be more than one flavor of a correct answer here. Are there possibilities for businesses purely to be in the data game? For example, might there be a company that offers its data services in an exchange model? Could there be a business that says, all buildings, send me your usage data in, and I will allow you buildings to benchmark against each other. So suddenly the building owner is free of the tyranny, if you will, of the building automation system vendor. The building owners are basically participating in a nationwide exchange of data with other building owners, which are all anonymized by this exchange. Sounds fanciful? Maybe, but so did E-Trade 15 years ago, the notion that people would be trading the way they do on E-Trade. Change does happen, it's just a question of when. Now all of this change is going to cost money, so who's going to spend the money? And why would they spend the money if the benefit goes to somebody else? And who then makes money through all of this? Because frankly, any industry where the participants don't make a profit is not going to succeed or stand alone as an independent industry for very long. So a bunch of questions, and I wish I had the answers, but I think the reason for laying these questions out is to really paint a vast or a broad canvas that we, as guys and ladies in the controls industry, need to grapple with and find a way of sharing these answers with each other so that some best practices can emerge. And just as there is a technology reference architecture that was emerging with the Industrial Internet Consortium, there probably are going to be more than one relevant business models that emerge as we grapple with these tricky questions. So that's a long session, for the first session. I hope we covered a few things that we promised we would cover in every session. Talk a little bit about a trend or two or some big news or big items that are relevant. Talk a little bit about what the technology aspects of these trends might mean and what the business aspects might mean. And in subsequent sessions, we'll try to cover similar kinds of topics. And then as we basically go through those topics, we will identify what the next set of topics might be. So please, if there are specific questions you have in mind or there are specific topics you'd like us to get into in greater detail, please feel free to let us know through Control Trends or directly to sierramonitor.com. So with that said, I wish you well, and until next time, keep networking and happy networking.